Alright, Earth people, we got this puck on a table, it's swinging around and around, and it's holding this mass up. And I really want to be careful on how I do this, so let's first of all just kind of spell out our goal. Okay, our goal is I want the V needed to hold big M up. And there's actually a rule here, kind of a physics idea that drives this whole problem. And the idea is that the tension that makes M go in a circle is exactly the tension that holds big M up. And now what we're going to do is some free body diagrams for each object. Just so, now I just want to make sure I'm identifying everything. So the mass here is 0.021. I have a radius of 0.2. And this is the mass of the second thing. So based on this, now I feel comfortable drawing my free body diagram since I've labeled all my variables. So let's do a free body diagram for little m and a free body diagram for big M and solve from there. So little m, it's got a normal force from the table, it's got its weight, and it's got a tension dragging it into a circle, dragging it into a circular path. Then we also have big M, the same tension that drags little m into a circular path is the tension that's holding up big M's weight. And now we can set up our equations. So for little m, I can tell you that normal cancels the weight because they balance. This is going to be a true equation, but we're not going to use it for very much. So I'm glad we wrote it down, but it turns out it's not a very useful equation for this one problem. We only write it down to account for these two forces so that later on we're not wondering why we didn't use those in a calculation. Next, the tension makes the little mass accelerate. And hopefully you've done enough of these that you're comfortable with my now writing this as mv squared divided by r. Now for big M, we have tension. It has a tug of war with the weight of big M, and the effect is those forces cancel, and the object is simply suspended in the air. Now I can go ahead and solve some things. So tension is big mass times g, and the big mass is 0.55, g is 10, so I'm getting a tension of 5.5 newtons, which I now use. Remember, the tension that holds big M up is the same tension that keeps this moving in a circle. So I have 5.5 equals 0.021 v squared divided by 0.2. Now the thing is, I don't want to do every step of algebra. I'm going to actually leave that to you. But I will say this. When you solve for v, the number that you will get for b is going to be 7.24 meters per second. So that's the solution to just about every problem in the packet. And I hope this is useful.